So I'm Mark Finch. I am mapping and ISV team lead at Greymatter, joined today by Justine and Miriam from Microsoft. Justine is technical evangelist and Miriam is principal program manager for Azure IoT and Smart City. So welcome guys and thank you for your time today. Quick agenda. We're going to start off with a piece about Greymatter, who we are, what we do. And then into the webinar, starting off with Azure Maps, location of things, and then onto Microsoft Azure, covering off Azure digital twins, connected urban environments, smart buildings, smart cities, city infrastructure operations, and that'll be topped off with a demo, and then we should have some time at the end for Q&A. So a bit about Greymatter to start with. Greymatter was founded in 1983 by developers. We offer software licensing, cloud services, and developer tools. Our main focus is on ISVs and developers, and also technical service providers and startups. We have a dedicated specialist geospatial location services team, which has been going since 2008. So Greymatter are a multi-award Microsoft Gold partner. We offer direct and indirect CSP agreements, so cloud solution, we're a cloud solution provider. We are a ISV royalty distributor, so for those ISVs who want to offer applications which are distributed for on-prem, you can use that type of license agreement for that, and a SPLA reseller as well. So if you are offering SaaS solutions, we can offer you the licensing for via the SPLA agreements. We are the #1 Visual Studio partner, and we have a team of dedicated Microsoft cloud architects as well. Our range of services, technical services focused on cloud migration and deployment to Azure. So one of our teams is Cloud Know-how, and those guys have the certified Azure architects. We offer application data modernization, source code compliance and security, DevOps consultancy. So if you're looking to move from maybe on-premise TFS to Azure DevOps, we have consultancy services around that. We have an Azure IoT practice, and we have a bespoke mapping migration services. So if you want to move from one mapping platform to another, then we offer services to assist you with that. So on with the webinar, over to you, Justine.
Yes, at this point, I'll dive in. My name is Justine Coates. I'm from the Microsoft Maps and Geospatial team, and I work in Maps for Enterprise. And Microsoft has had numerous mapping products over the years, but only a few have targeted the enterprise and allowed you to bring the power of Microsoft Maps into your products. And today we offer Microsoft Azure as our well, let's face it, it's our big data in the sky, and maps really offer a depth to that data. Understanding the location where something is often critical to the scenario that you're trying to achieve. In this case, we see that like my slide says, we see that maps are driving a lot of the choices people make. And I love statistics because they're always sort of just out there in the air. But we internally estimate that 80% of business data contains a location component, whether you are leveraging that or not. It can be critical to understand your business as to where your business sits and where you should sit to service your business. So we see geography as a component in a lot of those decisions. And so we look at this as the location side of the Internet of Things. So as you look at location intelligence, understanding and analyzing geospatial data can be an integral part of what you're trying to accomplish. As you see from my lovely slide here, we think about something as simple as a device sensor, or something as general as just generating insight from historical patterns from where things are. You can make data-driven decisions based on the location of things. And we blend in to these, likely more than these, but these large thoughts around mobility and logistics, tracking where things are, where they're going, Internet of Things, tracking the state of things, where they live, cloud, mobile, and edge to understand where you are in a particular scenario, and spatial analytics, that idea of, hey, I want to put a hardware store in a new location. Where am I going to get most of my customers? And you can learn more about us at the site below, but it's not a live link for you, so you can bing for that and find our blog. So what is Azure Maps? Azure Maps is a platform, a geospatial platform, basically geared to the Azure customer in mind, with a real focus on IoT and the location of things, understanding that we are supporting a huge data a data storage solution like Azure. We need to provide the basis for understanding location scenarios to that data. And so we offer a platform of geospatial APIs for the enterprise, that being what I like to call table stakes. Hey, you need a map, SDKs to help you do development, routing, understanding transit, search to find address, spatial operations about area and size and polygons and all that good stuff. Understanding traffic flow if you're doing something along the lines of logistics and transit. Knowing where you are in a time zone. All of these things are critical to be what I call table stakes. What you do with those is that you blend them into your solution so that they help you light up those location of things scenario. We are always working on building new capabilities, and we're always interested in what you have to tell us. We have a Microsoft Q&A tag called Azure-Maps. So if you go to Microsoft Q&A and you want to ask us any questions, we're right there for you, no cost. We'll chat with you about whatever question you have in the Microsoft Q&A site. And with that, I'd like to hand this over to Miriam.
All right. Thanks, Justine. Hi, everyone. My name is Miriam Berhane Russom. I'm a program manager in the Azure IoT product group. And in particular, I'm in a team called Smart Places and Energy. So our team focuses on anything that has to do with smart buildings, campuses, stadiums, cities, and the infrastructure that connects them, with a special emphasis on the energy grid. And my focus area within that is smart cities. So for this rest of the presentation, I'll talk about Azure Digital Twins, and in the context of also urban environments and smart cities. We are, we've been on a journey, and especially in the IoT journey for the past several years, in the industry at large, really on what we call connecting assets, right? With IoT coming up, really we've started seeing any sorts of devices being connected to drive operational intelligence. So, almost every business enterprise at this point has a connected device or an IoT practice, and it's been one of the key innovations, right, that's fueling really the digital transformation. And what we're seeing emerging, across different domains again, is what we're calling this intelligent environments, which is really about, not only, oh, Justin, I think, I don't know if this slide is timed. You go back to that previous slide, yes. Which is really, being able to understand the context of the environments in which, those devices and sensors are placed and where actions are being driven. And so when you start bringing actually the knowledge of the context, to the solution, that gives better decision in terms of actions that can be taken or any insights that can be taken. And then obviously we see also a lot of these domains interconnecting, and see with this future of, what we call this intelligent ecosystem that wants really to interact with each other. So actually I really like this graphic because, it shows, an urban setting or a city, you can see that there are so many things in play, whether they are buildings, whether they're stadiums, factories, the open spaces like streets, there are cars, there are street lights, there are EV charging stations, and all of those things are being connected, right? Increasingly connected. But for example, if we look at the building, you can start definitely, measuring the temperature in the building or the energy consumption, but by really connecting the assets like the HVAC system, the lighting system, and any other system that's in the building, and there's a proliferation of these connected solutions. However, when you bring this data in context of what that building looks like from a structural perspective, you can start reasoning across the data in a much more intelligent way. For example, the temperature, knowledge of a temperature in a particular room, it's different from a knowledge of the temperature in a hallway, perhaps. And in fact, if you add that together with other sensors like presence sensors, then you can drive other different decisions around how much ventilation that room would need or that the hallway would need. So we really think, a lot of these domains are actually starting to wanting to bring the context to be able to reason, and then increasingly want to interconnect. So for example, on the intelligent ecosystems, you can think of in a city space, just to think about there's a retail space and an urban space, and maybe those, they reason and their data will be in different silos. But however, if you start looking at the application, a retailer wants to understand the traffic of people or traffic of cars, whatever flow that's coming into that area, and that type of information and context, you actually get it from typically from the urban area. So those would be ecosystems or domains that start to interconnect to actually make better decisions about how a people's flow are going between urban spaces into retail spaces and other, or like stadiums is another example. So if you go to the next slide, this slide really shows what starts bringing the digital twin concept, and which is really about being able to fuse what we call the physical and digital by really having digital representation of often starts with connecting, as I said earlier, on all sorts of things. If you look at it like from left to right on this diagram, and really connecting things, you start getting operational insights. So there are a lot of value add applications that you can just do by connecting things with IoT. So, being able to do remote monitoring, fault detection, diagnostics, or predictive maintenance of those type of assets or that are being connected. However, as you start bringing the context of where those devices are, typical applications, for example, are being able to optimize flow, whether that's of goods or of people, really knowing the context of that space, being able to do occupancy and utilization, right? So, or for example, asset tracking across different type of spaces. And obviously, I mean, there are context and spaces, and ultimately there are people also in those places or spaces, right? Whether they're working, living, or doing other things. And so ultimately what really fusing this, insights, operations, and additional context you start to create solutions that really can enhance experiences, right, on people. So whether that's enhancing productivity of people or providing wayfinding experiences, or being able to provide additional comfort. And we have a lot of this type of examples, especially in smart building solutions. So if we look at what a digital twin is in the next slide, there's often, Justine, if you go to the next slide, please. Thank you. Digital twin could mean different things to different people, for sure. There's, it comes from, people will refer to geometry-based, applications as digital twins, or people will refer to just IoT-driven applications as digital twins, or applications that are doing simulation. So really, a digital twin is the solution, right? That's integrating data across, rich and complex data from a variety of sources, and it could be, obviously, data is coming from IoT devices, and really this is, about connecting devices, getting data from assets, and so on and so forth. Then there's really a view on the structure, being able to understand, the structure of any infrastructure, for example, and or an environment. And the entities that will comprise this environment and how they are connected, the relationship between them. Often this is, then gets brought to life, how we call it, with real-time data and sensors. So typical examples of this is if you look at a building and, the structure information of a building would be to say, hey, there's a building could be comprised by floors, and floors have rooms, and rooms can have desks, and so on and so forth. And all of this will be comprised in that relationship. And it can really create a graph using this type of structure. And now you can start also attaching real-time information to those entities, like room, for example. You can have temperature or occupancy sensors attached to them. Then there's really the geometry aspect, which it's all about the 2D, 3D design geometry, and in fact, with if you look at Azure Maps and everything that Justine said, for digital perspective, it really sits in that geometry box. And also, I mean, you can see that also geometries now are being enhanced with things like spatial anchors that are able to, anchor specific, objects or location into the geometrical representation. And there could be various applications that can be driven on top, obviously, on top of geometry information. Then you get to the behavior aspect, which is really about when you start bringing data in time series data, for sure. You can start doing all sorts of simulations, whether they are based on physics models or heuristics models. And so, there are also applications that really, cover the digital twin aspect from a simulation and this behavior perspective. Obviously, with as you start storing and data and get an historical insight of the data and all the other information, you get much richer applications. You can start driving other additional applications. But again, the information and the sources can also be obviously business data, or often this type of other sources and information will often fuel business data. So Azure Digital Twins, really, if you look at it, covers the structure aspect. It really sits there. It's a platform service that provides an easy way of, creating structure and modeling like entities, relationship, and bringing them to life and really connecting them to real-time sources. And if you look at Azure Maps, it really sits in that geometry. If you look at from Microsoft perspective, Azure, we provide really all platform services that will allow you, in fact, to create a complete digital twin solution. If you look at IoT data, there's IoT Hub. If you start looking at behavior, we can bring the time series service or ADX, and we have various solutions and platforms for storage, and then there's a wide variety of applications also to drive business data. So we'll dive a little bit more into the structure, which is more Azure Digital Twins. If we go to the next slide. Thank you. Yeah. So as we said, Azure Digital Twins, hopefully now that helps you contextualize where that Azure Digital Twins plays in the large spectrum of a digital twin solution. So it's a platform as a service, basically, that allows you to model any sorts of environment, whether those are buildings or factories, whether there are retail spaces, stadiums, manufacturing plants, and entire cities, for that matter. And then allows you to connect, really sensors, IoT data, and other business systems into the model. So using that now, right, as a PaaS service, you can build your digital twins solution and really being able to, control the present, which is doing all sorts of operational actions on top of it, track the past, or predict the future, which is really trying to do simulations and other things. So the core components of the Azure Digital Twin service, it comes with an open modeling language, which we call Digital Twins Definition Language, or DTDL. And that's really key. It allows you to model your environment as a developer. So, you can model anything really that matters to your business and what you're trying to drive. It's based on JSON LD and, allows you to describe any entity in terms of properties, obviously, but also telemetry, commands, for example, that those entities would be able to respond to, components, and then also relationship between different entities. This is also very aligned to DTDL on how we define IoT plug and play, so devices. So we really bring in that consistency of how you model devices and also environments. So DTDL is open source. And then we're also working through the Digital Twin Consortium to really work with a number of industry and the ecosystem at large that's really defining what digital twins means to the market. So once you defined, your environment through the DTDL, really then you use Azure Digital Twins service to really bring this into life, what we call to life. So the core part of the platform is this live execution environment that allows you to create your twin instance and relationships and make them really live. So on top of it, this becomes a graph, and there's a rich query and eventing systems that allows you to query the information on this graph using different parameters. So whether even like the properties of these entities, their relationship, and much more. And then you can use this event system really to drive any business logic on top of it. You could do any sorts of compute on top of it. Could be using Azure functions or any external compute. So it becomes really a rich live execution environment. From an input perspective, then it allows you, to input data from IoT or any business systems. So there's obviously a seamless integration with IoT Hub, but then you can use REST APIs to also ingress any sorts of data to keep driving your digital twin instance. From an output perspective, I mean, this pretty much, you can egress the data to any system, so whether it's to time series insights, storage, analytics, to Azure Maps. Really, if you're creating, this complete digital twin solution, this is where you start layering, right, the additional services to really create your application domain. So I'll spend a little more time into that DTDL next, and show you an example of what this means and how this works. So in DTDL, right, in more concrete terms, right, so what you start doing is you create your domain vocabulary, which means you're starting to describe entities and concepts that are important to your business. So in this example, for example, I have the entities that you see at the bottom. You can see like there's trying to model an energy grid, for example. And there is not really an expert of energy grid, but you can see there's some icons around substations, generators, a building, there's EV chargers, streetlights, and solar panels. And so these are the concepts that are important for me for, a digital twin solution that I'm building around maybe energy grid as it connects to buildings and different infrastructure in the city. And so those would become the entities that are important to me, right? So I'd start describing all these entities, and then I also describe with DTDL how these entities connect to each other. So for example, in an energy grid, there's connection from the generators to the substation to the transformers, or vice versa, and then those connect to different consumers or prosumers, like buildings, the EV chargers, or streetlights, as an example. And then what you're doing this entities also, you're describing the data and as well as the behavior. So that's what you're really doing with DTDL. So once you've described and created those entities, described the data and the relationship between them, then you start creating specific instances into Azure Digital Twin service, which means I can have a specific, I don't know, maybe I'm now looking at the energy grid in a specific city, let's say Bellevue, for example, or London, and I will instantiate this with the real instances that I'm gonna bring to the digital twin graph and really connect them in a topology. At that point, which is now, you see this, the graph to the right? So this is pretty much a specific instance that I have, and there will be a representation of this graph, right, in that Azure Digital Twin service. And then at that point, you're really describing eventing and processing on top of it. I'm not going really deep into the example of the energy grid, but this could be, for example, you could define some logic, business logic that says, hey, every time that energy or the EV charger consumption is beyond X, then turn off or something at the transformer or at the substation level, or it could be, hey, every time there is consumption of energy between those houses, those EV charger and streetlights, now you can look at the overall consumption at that substation level and drive other type of actions. So really, that's what you start doing and reasoning on top of the of digital twins in a graph like that. So one of the investments that we started doing, obviously, I mentioned energy grid, I mentioned buildings, I mentioned infrastructure in a city, and often when you start to build solutions of this magnitude as well, there's also different players that come into the picture. That are going to be data providers. For example, maybe the EV charger, it's an EV charger provider that's really providing that. The streetlight is, another party. The buildings, in the notion of the buildings, probably someone that's building a connected building solution. And so one of the things that was super important for us while, providing flexibility with DTDL to really model anything was, hey, a lot of these entities, there are standard definition, standardized definition of them, whether they're substation or buildings or streetlights or EV chargers, solar panels. And how can we make it easier for developers that are building on top of Azure Digital Twins to really give them some starting vocabulary, in this case, ontologies, we call them, to be able to create this type of solution much easier, right? Rather than you having to define now what a building structure looks like, could we use standardized definition for it? And the other thing is, especially when multiple players are coming to create a holistic solution like this, especially as we look at them in buildings or in this big spaces like campuses, stadiums, or cities, you actually need interoperability with these multiple providers. And so we started an effort to create this DTDL on ontologies that allows basically, that provide a base definition for domains that really are based on industry standards, and then that developers can use to create their digital twin solutions, but then that also are adopted and extended by the industry. So what we started doing is really evaluating industry standards that exist already. For example, we've already done that for buildings and cities. We're also working on for energy now. And really, because our goal is not one to create any new standards, it's really to adapt something that has been used widely by the industry, and also then work with partners that are experts on this industry and from an applied lens to really bring this into DTDL and really refine them if needed for the scope of this type of digital twin solutions, and then really validate it with use cases, with real use cases, so we don't stay into the standard world just for the sake of building standards, and then really deploy them, and then obviously drive them through open source, so make them available via GitHub repo, so really for more developers and partners to keep extending those, and then really evangelize them through the Digital Twin Consortium. And so with this effort now, we've announced two ontologies, one for building smart building solutions. So there's a full ontology based on real estate core to standard, and a consortium of parties, for that have developed this standard over years, and so was one of the most complete one in terms of this type of solutions. And so we've adapted that in the DDL. So you could actually start with that if you're looking for smart building solutions. And then we also worked on a smart city ontology that's kind of more broad in a way, because, you know, city can have so many things, but we really based it on the NGSILD standard, you know, from ETSI. We saw that was one of the things, the standards quite widely adopted, especially in Europe, and there's a huge community behind it, but also it focused a lot on the type of IoT solutions and digital twin solutions that we're seeing from cities, especially from this perspective. So maybe I'll spend a few more time on the smart city ontology next, and I'll show you in a live demo what that looks like. So in this case, right, when we're saying smart city ontology, by the way, we'll share these links later, but we have an IoT show and recording, as well as a blog about this that describes this. But at a high level, you know, when you look at cities, clearly it's a system of systems, and there's an ISO framework that I really like to use and decompose it. And so the ISO framework will decompose the city in infrastructures, in society and interactions as a whole. And if you look at the infrastructure, really look at the different type of infrastructure, whether it's mobility grid, whether it's energy grid, whether it's water grid, or the environment, or the built domain. And so when we look at the type of solutions that are really having a lot of interest, for example, a lot of cities have interest right now to be able to understand their air quality in the city or in a district. They want to understand their energy consumptions of specific areas as it relates to maybe streetlights, EV charging, or other buildings. They're interested to understand mobility flow, whether it's the people flow or traffic flow, and how that impacts things like you know, the other services that they need to do. And so we focused a lot initially on this type of domain, since we couldn't really boil all the ocean of trying to describe what a city looks like. So in this first take on the ontology, we really adapted models that describe, you know, environment, mobility, streetlights, parking, you know, so around all this type of solutions that we're starting to pick up, and cities are interested also from bringing IoT data perspective. And so we used ETSI and GSILD standard for that. And also we were able to compose that with another ETSI standard, which really describes more of the city topology and administrative area, obviously, to something that says, hey, a city has districts have, you know, neighborhoods in them, and so on and so forth, which allows now to place any sorts of infrastructure and give it some more context. And then also this gets tied to, you know, Sarah for City does that already, to the geospatial, the definition of a topology model overall of how any spatial object gets defined, which ultimately it could be this becomes, you know, if you want to do enhanced geospatial application on top of it, that would be the way to keep extending this model. So maybe I will go in my browser. So I will take it a moment from Justin. I will share my screen. So I want to show you a little bit this live with Azure Digital Twin Explorer and how this really comes to life.
Whilst you're just loading that, Miriam, if anybody wants to put any questions in the chat, please feel free to do so. We will have a Q&A at the end, but if you've got some ongoing questions you want to put in the chat, just go ahead and put them in there. Thank you. Perfect.
Yeah. So anyway, we're going to send all these resources here, you know, both the smart building ontology and how you can use this to really create smart building solutions with Azure Digital Twins, and also this Smart City ontology, and how you can use this to create solutions within Azure Digital Twin. So what I want to show you here, using this is Azure Digital Twin Explorer. So pretty much it's a tool that allows me to, it's a visual tool on top of an Azure Digital Twin instance. So in here, actually, right, in this ontology, you can, if in the Smart City one, if you open this folder, you'll find all the models that we've made available, open to everyone. So I mentioned, you can start seeing, hey, there are things like around being able to, the model air quality and measure that and look at that in the context of city. It could be noise, water, and other things. It could be, parking, could be around mobility. You see, this crowd flow, EV charging, and we're looking at traffic flow and so on and so forth as well. And you can really use this to bring it, create a solution. So maybe for those of you who are developers, I can show you quickly here some, so you understand the DTDL, right? So this is a DTDL model of, for example, in this case, is an air quality observed. And you can see this is JSON LT based. As I mentioned, like using properties, you could use telemetry to describe certain attributes. You can also use components, but you can create a very rich model and how this actually also relates to other entities. So for example, in this case, you see the clause around relationships, right? And in this case, there's a relationship of this model with a device that's going to measure this, or you could see also that there's a relationship with the weather observed model as it relates to that. In addition, you can look at all of this through the DTDL definition, but you can also use extends. For example, this allows you to create models in a much more object-oriented manner, especially around, you can create base classes and can create specialized classes that allows you to not to repeat information in so many entities, but also you can keep extending special entities. So, once you have all of this, now I want to create a solution on top of it. So in my case, I'm interested around, modeling the poles that exist in cities. So actually, I'll show you in this example. And pretty much, poles, for example, they are streetlights. A lot of cities are doing streetlight modernizations project to reduce energy, but also these poles, they get used to add additional sensors, whether it's air quality or traffic monitoring and so on and so forth. And so in this example, I'm interested actually to looking at an application around smart poles. And so I've used this ontology basically. So what I've done is I've loaded it in all the models here on my Azure Digital Twin instance. So the service that I've instantiated already. And so here you can see, I have city, I have, some of the element models that I was already showing you in DTDL. So they're all loaded here. And so from here, I can actually start creating entities, instantiating it. So for example, what I could do is, right, like this is a visual interface. You could do all this programmatically, but I could do, hey, I have EV charging, let's say EV1, right? At this point, so most I would have created a new instance on my digital twin graph. Obviously, I should connect this to my other entities. But before I do that, in here, I already created an instance of, I'm interested, I happen to live in Bellevue, so this is just more an example. And so you see that I have a city that's Bellevue, so all of this is using this ontology, and then you see I have, districts in the city, and then, I've started instantiating the poles that are in this district. So they all come from this ontology. Then you see that in each pole, for example, I have streetlights functions, I have air quality monitors, I can also add the EV charger and so on and so forth, right? So when we talk about, what you're doing with Azure Digital Twin is really creating a live graph. This is what it means, which means, you have, and this is much smaller examples, but basically you're creating an instance. It could be multiple of those, it could be a myriad of those, and pretty much this becomes a live execution environment. And so then you can drive this with, IoT data, with API sources, and so on and so forth. So, for example, if I show you in the streetlight, if this one works, so you could see that here, all the properties of the streetlights, that are defined from the model itself. And yeah, I haven't instantiated any value on this one right now. You can in fact see like their values is on, but you can think that I'll drive this to either IoT data, that's devices that are really controlling the streetlights, and I can drive this this data, right? So for example, I could start changing the value of the energy consumed values. And then pretty much I can also use, as I said earlier, like compute on top of this graph, for example, to also propagate, energy information all the way from the leaf nodes and say, hey, at the city level, I could have an energy KPI at the city level, for example. Here, I don't have it in this example. And then I could use compute as I'm getting streetlight energy information or the EV charger information. I can start computing it live in real time what the city's overall energy consumption would be, right? So that's how we start using this live graph and much more. So with that, if I will stop sharing. I had a few customer examples of how they're using Azure Digital Twins in cities and in building. Maybe I'll spend 3 minutes on that, and we can go into the Q&A. To the next slide. Yeah. So a few examples. So far we have, at this point, Azure Digital Twins has been, released as a general available service as of December 2020. But it's been on the journey and on the works for almost 2 years. And so we have a lot of partners and customers that are already using it in so many applications. And so these are some of my examples, especially in city. But probably many of you will know Bentley Systems, and Bentley Systems really, in fact, it has a lot of services and platforms for digital twins, especially focused on infrastructure. And really, so in fact, the iTwin service brings a lot of data sources like CAD information and geometry information, and using that, different infrastructure planners and others can use that to create, an environment, to build an environment, what that would look like, and so on and so forth. And so what Bentley has actually now integrated with Azure Digital Twins to be able to bring the live data so all the IoT data and information through this Azure Digital Twins integration. In addition, in the context of the city, Bentley Systems has also this platform called Open Cities Planner, which is really used by urban planners to be able to visualize city, be able to plan additional infrastructure, even being able to simulate things like pedestrian flows and so on and so forth. So this is one of the partners. And so in our first example, right, when we say, hey, Azure Digital Twins, the Digital Twin is a complete data integrator that brings data from multiple sources. And, you can see an example where you would use Azure Digital Twins for even digital twin solution that's already doing a lot of the geometry and CAD and visualization or simulation. The other one is MindSphere City Graph, and this is actually a new solution that was launched by Siemens at Smart City Expo in 2020. And so this is built on Azure Digital Twins and really allows, it's a new way of allowing cities to optimize their city operations. So it really starts creating this digital twin of urban spaces and infrastructure, and then integrates IoT data or any other data source, really to gain, for city operators to gain insights and also drive experiences that bridge to the citizen. And so this solution has won 2 awards, and the Smart City 2020 Smart City Expo 2020 award, and also an IDC 2020 Smart Cities and Communities award. And then from a smart building perspective, we actually have much more customer stories on smart building. It's been at least one of the areas where we've seen earlier on all the use of digital twins, and also where the Azure Digital Twins also was born, was from really smart building solutions. But so Brookfield Properties, again, is using Azure Digital Twins, using the Willow Twin solution that really allows them to operate efficiently their buildings, their properties. And so in specific, One Manhattan West, which is a huge building in the middle of New York, is actually using that. And as you can see in the bullets, this digital twin-based solution allows them to lower operating costs, optimize energy usage. They're using it to create additional experiences to the tenants, and also, create efficiencies on their employees. So those are a few examples. And with that, finish my slides here, but we have a few minutes for questions.
Thanks very much, Miriam. So we've got a couple of questions. We can also open the mics, I think, if anybody has any particular questions, but I've got a couple here already. So first one is, how well does Azure Maps interact with IoT Central and Azure Sphere products?
Yeah. Azure Maps is, and Justine can add to that, is well integrated with all the Azure IoT products, in particular in IoT Central. And I used to work in the IoT Central directly platform, and so it's actually Azure IoT Central. As you're creating your connected asset solution, you can use it has a Maps function within that, which is an Azure Maps function, and you can use that to plot where all those devices and the connected assets are, and also create some geofences around it. And there are also much more planned. Justine, I don't know if you want to.
Yeah, it's designed for it. That's all I got to say. There's a reason it's called Azure Maps.
Perfect. Thank you. And the second one is, as Azure Maps is a resource, does it have the same level of compliance and security as other products on Azure?
Well, like many things in Azure, it has a different coverage matrix. Maps are huge data, so it's not able to be geolocated. It's everywhere geo. So a lot of people are looking for data to not leave their particular Azure region, and Azure Maps doesn't offer that. So Azure Maps is regionless. So that's really the big difference from Azure Maps to some other items.
Perfect. Thank you. That's all the questions I have. Does anyone else have any questions they want to ask? Okay, we can just go to the last slide then, Justine, just to get a couple of points over. So if you've got any questions that you want to raise, please get in touch with us. There's our email address, mapping@greymatter.com, and our phone number there. Greymatter are running an IoT program in partnership with Microsoft. We have potential funding for companies who have IoT projects. The program includes design workshops, business model creation, and helps you with your GTM strategy. It also includes 5 days of professional services. There is quite a lot of interest in the program, so if you are interested, I urge you to get in touch very quickly because the application's deadline is at the end of the month, 30th of April. So if you are interested in getting some more information about that, please contact us there on the details you see on the slide. And finally, if you've got any questions around Azure or Azure Maps, if you want to discuss your use case or if you've got projects coming up, please feel free just to contact us. We are more than happy to provide you with technical services and help you get your project underway. So thank you very much, everybody, for joining, and thank you, Justine and Miriam, for a very interesting webinar.